Okay, folks. Full screen this. I did not erase that. That is so hilarious. Okay, just like a true whiteboard, guys. Gotta erase everything. Okay, so we are looking at the examples for today's lesson where we are finding the missing component, whatever that may be. All right. So we're looking at the first example. Miss Gates is baking circular pies because she's bored during quarantine. So are we. Can I get an apple? The first pie she bakes has a circumference of 18 pi inches. What is the diameter of the pie? So the steps to us finding this is, first I need to figure out what I'm looking for. What am I looking for? What is my unknown? My unknown is diameter. The next question I'm going to ask myself is, what do I know? What does the question automatically tell me? What the question does tell me is that I have a circumference of 18 pi. And then the next thing I need to ask myself is, what formula, where can if I can dig in my treasure chest, what is one thing that I can take out, or even two things? What can I take out of my treasure chest to help me find what I don't have using what I do have? So what formula has circumference and diameter? I'm looking over here at my treasure chest, and I notice that I have this formula: circumference equals pi times diameter. And so far, the only things that I do know is that I have pi, I have diameter, and I have circumference. No, I have pi, I have circumference, and I'm looking for diameter. So I'm going to use this formula, and I'm going to plug in what I do know. That review on that last page is going to be super helpful in us remembering inverse operations so that we can get rid of things to find what it is that we need. So I know that circumference is equal to 12 pi. And 12 pi is equal to pi times diameter. Now, what I'm trying to do is I'm trying to figure out what is the what is diameter equal to, which means I'm going to have to use inverse operations to get diameter by itself, which means on this next line, the first thing I'm going to have to do, gotta be kidding me. Okay. That's my little line right there. And to get diameter by itself, I need to divide by pi on both sides. That kind of rhymes, you see what I did there? So I need to divide by pi on both sides. Obviously formatting sucks. And this is gonna help me understand what diameter is. So let me just go and switch over to a marker or something so that we can see what's happening. So pi divided by pi is 1, so that cancels out. And then 12 divided by pi, the pi divided by pi part cancels out. So what you ended up being left with is 12 divided by pi, 12 pi divided by pi just leaves me with 12. And we're saying that 12 is equal to pi times d divided by pi, which those two cancel out. We know that the diameter is equal to 12. And if we were to put this back in our original equation to find the circumference, we should get that. So circumference should equal pi times diameter. And if we were to substitute this back in, we should be able to find that pi is equal to 12. That circumference is equal to 12 pi, which it is, because when we simplify this as far as we can go, circumference equals 12 pi. So that would be the example for example 1. If you want to take this a step further, you could turn 3.14 into pi, and that you would get an approximation of the circumference, but 12 pi is the most accurate one. Okay, let's look at example 2. Sorry, I'm gonna give you a chance to look at this some more, get it copied down, study this a little bit, pause the video if you need to. I'm gonna set up for example 2. Okay, back at it again, example 2. The second pie Miss Gates bakes needs to be approximately 25 pi square inches of dough to cover the pie. when we see the thing square inches, we automatically, that's a clue for us. And we're gonna talk about what that is in a second. How long will the cut of her first slice be? So this is like using some very creative language to like tell us a couple of things. First, I need to figure out what I'm looking for. That lies in this question right here that says, how long will the cut of her first slice be? Now, when you're thinking about a slice of pie, you automatically know that you're not gonna cut it across the middle. You're gonna like cut from the middle to the edge. You wanna know, so we wanna know how long that slice is gonna be. We're describing the radius. That first cut of a slice, if you like think about us cutting open a cake or a pie, we start in the middle and then we cut to the edge. So we start in the middle, we cut to the circumference. That is what we're looking for. So the unknown equals radius. And the known, what are some things that we know? Well, we know for one that she needs approximately 25 pi square inches. What is 25 pi square inches? What do we know about square inches? Anything that's squared is area. Anything that's cubed is volume. So what this is describing is our area of the pie. That 25 square inches is like the clue that now we know that we're dealing with the area or how much space the circle takes up. And we can use the area to find the radius. I'm looking for what formula is going to help me understand, like what formula can I use that has radius and that has area. I'm looking at my treasure chest. What formula can I use to help me find my unknown? And I'm looking at this formula right here that says area equals pi times radius squared. So I'm going to take that formula, throw it into my workspace, and I'm just going to begin filling in what I do know. I do know that area is equal to 25 pi. And 25 pi is equal to pi times the radius, which is something that I don't know, squared. Now I can use inverse operations to figure out everything that it is that I need to know. The first thing that I know is that I can divide by pi on both sides to get r squared by itself. Just kind of clean this up a little bit. If I had like a whiteboard, this wouldn't take as long, but I feel like this makes a lot of sense and this is easy for everybody to watch. So that's why I'm doing it this way. So first thing I notice is that the pi's cancel out. So we've gotten rid of pi, and when we go back into this to do the next layer, we are just going to be left with 25 is equal to radius squared. Now, we talked about this a little bit, but something that we have to get familiar with is understanding how to find the square root of a number. And when we're thinking about square root, we're just basically saying the radius multiplied by itself. So let's like break this down a step further. 25 is equal to the radius times the radius. Because the radius times the radius is the same as saying the radius squared. So the radius times the radius equals 25. Now this is a question that like has a few ways that we can like ask ourselves this, but basically the question we need to ask ourselves is what number times itself is going to give me 25? This is a very easy one. Like there's a number that this number times that same number gives us 25, and we know that to be 5. So we can like plug that in and like double check and be like 5 times 5 equals 25, which we know is true, which means the radius must be 5. But let's go back and like think about what's another way that we can solve this. If I knew that r squared equals 25, I could say I want to find, we want to find the square root of 25. So to do that, we just do the symbol for square root, which looks like that. The square root of 25 is equal to r times r, or r to the second power. But actually, what ends up happening is, in order for us, let me take a step back. In order for us to find the value of r, we have to get rid of the exponent. And to get rid of the exponent, we have to do the square root on both sides of the equal sign. So what we're basically saying is, I want to know the square root of r squared. This is how we cancel out the exponent, by doing square root. But because we did it to this side of the equal sign, we have to do it to the other side. Since we did the square root of r squared, just so that we can get r by itself with no exponent, we have to do that same thing to this side. And then the math laws tell us that we will find the true value of y when we do this. I mean, the true value of r when we do this. So the square root of 25 is 5. And I'm going to go to my calculator and show you guys like how that works out in a second. But the square root of r squared is just r, and the square root of 25 is 5. And we're going to go to the calculator just to like show how this looks and how we can define this. So the little square root function is, which one is it? So we'll type in 25, and then we'll do square root. It's the 2 with the square root symbol and the x. It's gonna look different on other people, so if you need to go and use a scientific calculator on Google, then you should totally do that. But this is the idea of what happens. The square root of 25 is 5, and so you know that the radius is 5. If we wanted to check this, we could put it right back into our original example, into our original equation, and we should get the same radius. I mean, the same circumference. So what I mean by that is we start over with the area of pi times radius squared, and then we plug in the information that we do know. You know that is pi times 5 to the second power, 5 squared. Area is equal to pi times 5 times 5. And we just like solve it step by step. And the final answer would be area equals 25 pi. So that's how you use inverse operations in algebra to find the missing value of something. If you need to pause this or like what have you so that you can get all of these steps in, be my guest. The treasure chest is a thing that's definitely going to help you, especially like when you just need to keep your formulas on the top of your brain. This treasure chest is going to be ever growing, so definitely make sure that as mine grows, you just have a page that's just for formulas and like useful ways for you to find out and figure out really complex stuff. All right. Looking forward to seeing you guys' answers to this. That's all I got for today. Do well, try your hardest. Do not rush through this stuff. Don't play yourself. All right. Peace.